In this problem, we're given two vectors in polar form, and these happen to be velocity vectors. And what we're interested here is actually the vector difference, v2 minus v1. We're asked to compute the vector difference in polar form, and we want to express the angle as an angle less than 90 degrees with respect to the horizontal. And we're asked to express this answer to three significant digits and draw a sketch of v2 minus v1. And I'm going to start with the sketch, because the vector difference, when two vectors have their tail in the same place, has a simple geometric interpretation. This is going to be the vector pointing from the head of v1, that's the one you're subtracting, to the head of v2, that's the one that came first in the difference. So now we have a rough geometric sense of what our answer is supposed to look like. And now we can get into taking this vector difference by breaking everything into components. So I'll start with the x component, and the x component for v1 is going to be a 20 cosine of 55, but in the negative I hat direction. So this gives me negative 11.5 I hat. Then I look at the y direction. The y component of v1 is going to be a plus 20 sine of 55 j hat. And this gives me 16.4 j hat. Then we decompose v2. The x component is a 15 cosine of 20 degrees I hat. And that's about 14.1 I hat. The y component, 15 sine 20 degrees j hat. And I get 5.13 j hat. Now we can compute the vector difference in component form, and v2 is 14.1 I hat plus 5.13 j hat, and v1 is a negative 11.5 I hat plus 16.4 j hat. So we distribute the minus sign on that second term. That gives me a positive 11.5 I hat and a negative 16.4 j hat. And then we just combine like terms for these unit vectors. And this gives me a total of 25.6 I hat minus 11.3 j hat. And we should go back and make sure this agrees qualitatively with what we're looking at in the picture. So I'm claiming the x component of the vector difference has a length of 25.6 in the I hat direction. And then the y component of the vector difference has a length of 11.3, and that's in the negative j hat direction. If I compare to the magnitudes that I see in the picture, like v1 has a magnitude of 20, it looks pretty reasonable to say that the x component of the difference is 25.6. Same with the 11.3. If v2 is 15, then the length of this y component is pretty reasonable to say that looks like about 11. So the final piece of the puzzle here is we want to get the direction of this vector difference relative to the horizontal, and we want to get the magnitude of this vector difference. And that just takes the Pythagorean theorem. So we'll go ahead and do the magnitude first. And we want to notate the magnitude. And one way to do that is to put double absolute value bars around the vector difference. Into 3 sig figs, this comes out to 28.0. And the units here are meters per second because these were velocity vectors. And then our angle relative to the horizontal is going to be an inverse tangent, 11.3 over 25.6. And our convention is to always express angles as a positive number in degrees. So I'm not including the minus sign on the 11.3. We can see in the picture that we're below the horizontal, so it's not necessary. And to 3 sig figs on this, I get 23.8 degrees below the horizontal. So there's our magnitude of the vector difference. And there's our direction expressed as an angle less than 90 degrees with respect to the horizontal. And we're done. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left. Or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.